Okay guys, so today we are going to talk about integration by parts. We use integration by parts whenever we need to integrate product of two functions. Before we start integrating, we need to know the product rule of differentiation. So if we want to differentiate two functions, suppose r times s, product of two functions with respect to x, it's given by, we all know, dr dx times s plus r times ds dx. Okay, so just a little bit of manipulation. So this r of x times ds dx is then given by d dx of r of x times s of x minus dr dx times s. Okay, so let's call this, say, equation 1. Now we see that we here have ds dx, we here have s of x, and we here have s of x. So how do we get s of x from ds dx? Like, how do we get s from the derivative of s with respect to x? We integrate the derivative, right? So when we do that, so when we integrate ds dx with respect to x, we get s of x plus an arbitrary constant c. Okay, so let's call this equation 2, and we're gonna plug equation 2 into equation 1. Okay, so plug 2 in 1, then what do we get? We get r of x times ds dx is equal to d dx of r of x, and s of x is given by, okay, so let's from here, and let's not call this equation 2, let's make this s of x is equal to, from this relation, s of x is given by the integration ds dx with respect to x minus c. Let's call this equation 2. Okay, so then when we plug equation 2 into equation 1, this r times ds dx is given by d dx of r times s, which s will be given by equation 2 now. Okay, so this would be nothing but integration ds dx with respect to x minus c minus dr dx. Again, s would be given by this thing from equation 2, which is ds dx with respect to x minus c. Okay, so if we just simplify this a little bit, this would be given by d dx of rx times integration ds dx with respect to x minus c times d r dx, c times dr dx, then minus dr dx times integration of ds dx with respect to x plus this minus minus plus c times dr dx. And we see that these two terms with that arbitrary constant c which came from the integration of ds dx cancels out. So this becomes therefore r of x times ds dx of x becomes d dx of r of x integration ds dx of x with respect to x minus drx dx times integration ds dx with respect to x. Okay, now we call this equation 3. Now let's get back to our integration. Okay, so we suppose need to integrate p of x times q of x, okay, with respect to x. Now let's write here, rewrite what we got, our r of x times ds dx. Okay, so rewriting again from before, just so that we can see it in our current screen. R of x times ds dx is given by ddx, okay, ddx of, okay, ddx of rx integral ds dx respect to x minus dr dx integration ds dx respect to x, and this was equation 3. Okay, so now that we know equation 3, we have to first make an analogy. We have to make the analogy that this p of x is analogous to r of x in equation 3, this r of x, and q of x is analogous to ds dx in equation 3. Okay, so this p of x is analogous to r, q is analogous to ds dx. So we just now replace this p of x and q of x with the corresponding right hand side of equation 3. Okay, so then this will become is equal to integration whole thing, r is analogous to p, so this remains now ddx of, okay, rx, r is remains p times integration ds dx, and ds dx is analogous to q, so integral q of x dx minus, then again dr is analogous to p, so dp of x dx integration q of x dx, ds dx is q, right, the whole thing dx. Okay, so then this becomes is equal to integration now ddx of p of x integral q of x dx minus integration dpx dx integral q of x dx. When we integrate the first one, the derivative of this thing with respect to x, you get the integrand back plus an arbitrary constant c1. There's no arbitrary constant from the integration of q of x dx, right? Because there was that c which got cancelled when we integrated ds dx, remember? So that doesn't count. So this constant comes from the integration of the outside this dx. Similarly, this remains, you have to integrate that dpx times integration q of x dx, and similarly when you integrate this outside, you get another arbitrary constant, and you can add those two arbitrary constants to form a single constant, and the result is given by then dp dx qx dx plus c, and that's how you do integration of px times qx dx. Thank you.